And welcome to our next section, 2.1, where we're going to be talking about graphing. If you know how to do stuff, instead of just assuming that you know everything, skip past the things that you know so that you can get to maybe some things that you either don't know, never learned, or forgot. What we're going to do today is we're going to talk about plotting ordered pairs, graphing equations by plotting points, finding intercepts of a graph given an equation, and then we're going to find the midpoint and the distance between 2 points. And I'm not really much for formulas. I'm going to actually kind of explain to you how they work, and then after that you can do whatever you want. You can use formulas or you can do what I would do. We have to have a set of ordered pairs, a pair of numbers that is an x value and a y value, for which an equation is true, where the order does matter. Whenever you see an ordered pair, you'll see something like this, x comma y. And why do we need two numbers to plot a point? On a number line, you only need one value, but now we're going into something that's two-dimensional. A number line is one-dimensional. This is a Cartesian plane. It's two-dimensional. Since it's two-dimensional, we need two different numbers to plot one point. For example, let's say you told me that you live on Main Street. Here's Main Street. And unless it's a city where there's only one house on Main Street, that probably won't help because Main Street may be a long road and I don't know which house is yours. That could be one coordinate. Let's call this our x coordinate. But for me to find your house, you might want to say, I live on the corner of Main Street and 5th Avenue. Now I know my house is right here, because if this is a street and this is a street, then where I live is on the corner. Now I know where you live. But if you just tell me you live on Main Street, or you just tell me you live on 5th Avenue, I won't know exactly where your house is. That's why we need ordered pairs, because we're using the x and y, and where those two numbers intersect, that is the point. We have now the graph. We call this the Cartesian plane. It's also called the coordinate plane. There's a lot of names for it. Sometimes you call it rectangular coordinates. We have these two axes. The x-axis is always horizontal, and the y-axis is always vertical. And where they intersect, and that's called the origin. That point is 0, 0. This is 0, 0, which means I'm not going anywhere in the x direction or anywhere in the y direction. And then we take this square, and now we've divided it into 4 different pieces. And each one of those is called a quadrant. We start in quadrant 1. In quadrant 1, my x values are all positive and my y values are all positive. I'm starting where everything's positive. If I go in this direction, I'm going positive. And if I go in this direction, I'm going negative. We know that from a number line. Then when we go up, it's positive. And when we go down, it's negative. If I start at the origin and go to the left, then the x value is negative. And here in quadrant 2, we can see that our x value is negative, but our y value is above the x-axis, which makes it positive. And in quadrant 3, they're both negative. And in quadrant 4, the x value is positive, but the y value is negative. Here's my x-axis, and here's my y-axis. The horizontal axis resembles a regular number line. Now this is like a number line, only it's vertical. So I go up and I get positive values. And when I go down, I get negative values. If I want to plot -2, 3, remember, this is an ordered pair. And the order matters. That's why it's called an ordered pair. First look at x, and x is at -2. I don't actually want you to do this when you're doing your work. I'm doing this just so that I can help you understand. There's my x equals -2 line. That's my y equals 3. And where they meet, right there, that is my point, -2, 3. We're not going to make these dots, but I'm showing you this is the point of intersection. If x equals 0, then I'm not moving off of the origin because this is my 0, 0 point. So x doesn't change, but y does. We go up 4. This point right here, this is 0, 4. And then 2, 5. I go over to the right 2, and then I go up to 5. And that's my point 2, 5. And then lastly, we have 4, 6. We go to 4, which is right here. And then we go up to 6, which is right here. And that would be 4, 6. Whenever I'm going to the right of the y-axis, whenever it's positive, I'm going to the right of the y-axis. And whenever x is negative, I'm going to the left of the y-axis. Whenever y is positive, I'm going up from the x-axis. Whenever y is negative, I'm going down from the x-axis. If I wanted to sketch this graph, we haven't really talked about what a graph of a squared function looks like. But a graph of anything squared is called a parabola. It looks like this. Or it could look like this. Or it doesn't even have to touch the axis. It can move over to the left or right. How do you sketch this graph? With the information that you have at this moment, to graph this, you need to make a table. The table is going to be x, y. Pick some numbers and plug them in. Let's say when x equals 0, I plug 0 in for every x, and I get y equals 4, because the first two terms disappear. When x equals 1, I plug 1 into here, and I get 1 squared, which is still 1, minus 4 times 1, which is 4. So I have 1 minus 4, which is -3, plus 4. -3 plus 4 is 1. Let's just start graphing some things. So 0, 4 would be right here. And 1, 1 would be right here. What we need to find out, is it facing up or facing down? And if it's facing up, where's the very lowest value? Let's see what 2 gives me. 2 gives me 4 minus 8 plus 4. That's 0. Now I have 2, 0. I still really don't know. It could go below the x-axis. So let's plug in 3. When I plug in 3, I get 9 minus 12 plus 4. 9 minus 12 is -3 plus 4. That's 1. Notice now I'm starting back up. And I'm sure if I put in 4, I'm going to get my answer to be 4, because it's always going to be symmetric. So let's see what that looks like. If I plug in 4, I get 16 minus 4 times 4, which is 16, plus 4, which gives me 4. So I have 4, 4. And I can tell now that I've found the center, or what we call the vertex. We will learn about it later. And that's the lowest point, or if it's facing down, it would be the highest point. Since this point and this point are equal, and this point and this point are equal, this has to be the center. That means that the vertex is at 2, 0. Now, we're not asking for the vertex yet, but you do have to put in enough points to tell when it's starting to go back up or go back down. Anything you don't know how to graph, that's how you graph it. The other thing we have to understand is how to find intercepts of a graph. What does that mean? Let's say I have a line and it looks like this. Where the line hits the x-axis is called the x-intercept. And where the line hits the y-axis, it's called the y-intercept. And I just want to talk about it for a minute because I'm going to tell you how to find them. But unless you understand, then you're memorizing. Well, if I were to plot a point here, or a point here, or a point here, or a point here or here, I know that the y is always going to be 0 if this was my point right here. Remember, the y is going to be 0. And if this was my point, then it would be 2, 0. And if this was my point, it would be 3, 0. And if I went negative, it would be the same. What all those have in common is that whenever I have an x-intercept, that means it's touching the x-axis. And when it touches the x-axis, y is always equal to 0. And the same is true for the y-axis. Anytime I'm on the y-axis, if you plot a point anywhere on the y-axis, because it's on the y-axis, we haven't traveled anywhere in the x direction, so x is going to be 0. Here's an example. Find the x and y intercepts of the graph of the equation y equals 2x minus 1 over x plus 3. The easy one is the y-intercept. Why is it the easy one? Because we said x equal to 0. And whenever x equals 0, I just plug in 0 and I find an answer. So I would have y equals 2 times 0 minus 1 over 0 plus 3, which is, well, 2 times 0 is 0, so I have negative 1 over 3. My y-intercept is at negative 1/3. If I wanted an ordered pair for the x-intercept, if it just asks you for the value of the x-intercept, it's negative 1/3. If it says, what's the ordered pair? Well, I already said x equals 0. That's where I started. And when x equals 0, y equals negative 1/3. So that's the place where this graph crosses the y-axis, okay? Now, if I want the x-intercept, again, this time I set y equal to 0. This is usually a little more difficult. So I'll say y equals 0, which equals 2x minus 1 over x plus 3. But let me erase this. So the thing about this is, if you think about it, I only really need to make the numerator, or the top part of the fraction, equal to 0. Because 0 divided by anything is 0. I'm going to do the algebra, but just if you understood what I just said, then all I have to worry about is if when 2x minus 1 equals 0, the whole thing equals 0. Because if 0 is in the denominator, then it's undefined, right? You know that. But if 0 is in the numerator, then the whole function equals 0. So what I can do is, I could either just set 2x minus 1 equal to 0 and solve for x, or I'm going to show you the algebra behind it. So we have x plus 3. I'm going to multiply both sides by x plus 3, right? And then this x plus 3 is going to cancel with this x plus 3. And 0 times anything is still 0. So I end up with 0 equals 2x minus 1, which is basically what I just said. All you have to worry about is the numerator. Okay? So I add 1 to both sides, and then I divide both sides by 2. I get x equals 1/2. And if I wanted to put that in ordered pair form, I would have 1/2, comma 0, because I already know my y is going to equal 0 whenever I'm looking for my x-intercept.